Hello learners, welcome to Manifested Online Classes. My name's James Kenyani. We are still continuing to build up on our topic on loci. So last time we had given, solved some questions and given you 2 more to solve at home. So the 2 questions given are here on the board as the assignment I had given you. So question 7 talks of state and sketch the locus of the variable point t, which is equidistant from 2 fixed points P and Q. The second question talks of also stating and sketching the locus of a point P, which is always the same distance from a fixed point X. So we go to the solutions. We go to the solutions in question 7. For question 7, I need geometrical instruments. That is a pair of compasses and a ruler. I need a pair of compasses. For those who don't know, a pair of compasses, it is this one, and that is the ruler. So I'll need these to internalize or to explain that. So we go to the question. The variable point t, which is equidistant from 2 fixed points P and Q. There is a word there, equidistant. That's in fact the law. Equidistance. Another simplification of the word equidistant is at equal distances. Equidistance, at equal distance from the 2 points. So I'll go straight to that. The first thing you do, you have the point, a variable point t. So there are 2 points P and Q. So first of all, draw a straight line. You'll draw a straight line. On the straight line, you'll get, there are 2 points, P, Q. So you have your point, just use this. We have P and the other point is what? Q. Those are the 2 points you have. So that point, variable point, is the one we have to get. And it should be at equal distances always from point P and Q. In short, they are just actually asking you to get a perpendicular bisector of line PQ. If you get the perpendicular bisector, it will be, any point on that line will be at equal distances from point P and Q. So I'll put my ruler down and use my compasses. So to bisect that, I'll go at P. I'll go at P. With that compass, ensure that the first arc is at least more than a half the line PQ. More than a half. So strike an arc above, strike an arc below. Remove it at P, move to Q, and using the same distance, strike an arc below, strike an arc above and below. Then remove that. You realize this was rubbed a bit, so that was just the point P and Q. So the two intersections I'll join using a ruler. I'll join using a straight edge, a ruler. So I move my ruler there. And draw my line. I'll draw my line. The line I've drawn is actually the perpendicular bisector. I've actually got the perpendicular bisector. This is perpendicular bisector of PQ. So any point on that line, any point, whether it is here, if you measure the distance from P to Q, it will be the same as from that point T to Q. So the locus of that point, you come and write your answer. The locus of the variable point T will be the perpendicular bisector of PQ. That is your solution. It will be the perpendicular bisector of PQ. Any point on that line will be at equal distances from P and Q. So the locus is actually the perpendicular bisector of that line PQ. We'll move to the second question. A point P which is always the same distance from a fixed point X. So just to start that, I'll need a pair of compasses. I'll need a pair of compasses. So we go to the solution of question 8. Question 8. So there is a law there which is always at the same distance. Always at the same distance. So I'll have in question 8 to identify what? My point X. Identify your point X. So since it is at equal distances, you can actually get a good picture of this. For those who did tethering, when you have a cow, you tether it on a peg. It is able to move around. The maximum it can stretch will always be equal distance from the center of the peg. But this is a point which is free to move up, down, in any direction. So I'll take my pair of compass, this one. I'll come with X as my center and with an equal distance with X as my center. I'll draw, you know it's equidistant, so I'll draw that. I'll draw that. So that is from point X. So one of the path the point will take is what? What can you see on the board? Everybody knows that is a what? A circle. Everybody knows that is a circle. That is one of the paths that variable point P will take. But the point A is free. You are free to turn it in 3 dimensions. So it is even able to take up other paths. It is even able to take up other paths, so long as it is as a. So you can actually, I dot that to show that. So I can write here other paths taken, other paths taken to complete a sphere. So don't wonder what a sphere is. A sphere is like a ball, round in shape, an orange, a sphere. So the answer to that, the locus will be, so you'll come and write the locus of the point in question P, the point P will be a circle, or a sphere, It will be a circle or a sphere. So having solved question 8, before the conclusion of this lesson, I'll be able to give out 2 more questions which will solve at your own free time. So I'll write the questions on the board. So I'll get some space, or I have space there. Question 9, assignment. So those are 2 questions. Question 9, you state and sketch the locus of a ball which rolls such that it is always 4 meters from a straight wall. 10, you also state and sketch the locus of a line AB rotated through 180 degrees from A. Having given the 2 questions, it is a pleasant time for you to go and get the solutions for that as you continue remembering what we defined as a locus. So thank you very much for your audience and have a nice time. Bye.